How are you, everybody who is watching this fantastic video, and how are you, some physical students in this class? I would like to take this opportunity to welcome some physical students and even also some online or non-physical students into our very interesting online school or online college that called the Tanzania Online Full Technical College. It's the first time to meet me. Well, you don't have any idea about me. It's not a great deal. My name is Olenjolain Moko Tayai Losingo. Simply just call me Olenjolai. I thank God by His own grace and the gift of teaching, who have given me gift of teaching and the gift of engineering. I love teaching. I like engineering. So I would like to take this opportunity just to introduce you quickly about what you are doing. In this online institution or online college, full technical college, we are here to train and mentor actual teenagers who wish to be practical and theoretical engineers. And we are dealing with students from different fields, but especially the students from the field of electrical engineering. So I would like to tell you that maybe you can ask yourself a question, whether these contents are just have been prepared for you. Well, so I want just to give you a quick review about who did I target in this content. This is a very interesting and powerful online technical college. We don't have any physical technical college, but we just have just online. That's called Tanzania Online Full Technical College. So in this college, actually, we are training students to think as basic technician and full technician. So we prepare the contents actually that we transform our student from the knowledge of mathematics and science into the knowledge of applications. It means that the engineering and technology. And I want to tell you that the contents that we are going to discuss in this mode of electronics drawing are actually, these are the fundamental contents and are very crucial in any level of engineering, whether it's a diploma level or undergraduate level or postgraduate level, such as master degree in engineering or even PhD studies. Because drawing is actually, it's a language. So whenever you want to communicate with other engineers about something, or about a particular maybe solution that you have, or about particular system, it's better to communicate by using drawing. So we have some departments in our online school. One of the departments is called electronics engineering. In this electronics engineering, we are teaching different modules. One of the modules is called electronics drawing. However, that we have some physical students who actually are teaching them, who are pursuing ordinary diploma in electronics and telecommunication engineering at Dar es Salaam Institute of Technology. But we are not limited with DIT or Dar es Salaam Institute of Technology. These contents might benefit any serious Tanzanian students who wish to be competent in drawing, and especially with competency-based training education. Then today we are in chapter 1 that's called Introduction to Electronics Drawing, and our lecture 3 will be focused on difference between electronics drawing and electronics drafting. These contents can help any serious teenager or Tanzanians or even non-Tanzanians who pursue diploma in electronics or bachelor in electronics, diploma in telecommunication or bachelor in telecommunication, diploma in mechatronics or bachelor in mechatronics, diploma in computer engineering, bachelor in computer engineering, diploma in electrical engineering, bachelor in electrical engineering, diploma in computer, just we call it computer science. Yes, however, that is not a great deal for the computer scientists, but diploma in biomedical equipment or renewable energy. So I believe that you are ready. This is the serious program. It's a serious module. We'll be delivering a number of concepts in your mind. Get prepared to draw electronics drawing. Get prepared to understand and apply the drawings on solving simple real-life engineering problems. So I believe that you are ready. Take your exercise book, take your pen, take your pencil, take your ruler, and then take your drawing papers, because we'll be having some drawings in this program. And take your exercise book, have a fresh mind, and then receive the good news that you are going to deliver. Let me appreciate some physical students so that you can hear them while they say something. And this is the active class. I'm going just to teach you, and also you're going to teach me. So we are going to teach each other. In most cases, I will ask you to reinforce understanding, to pronounce the terminologies, but also in case you have a question, don't hesitate to ask me, whether at the beginnings of the class, or maybe in the middle of the lecture, or even at the end of the lecture. So let me and you, just let me greet you again and appreciate you and hear something about whether you are ready to receive information or you are not ready to receive the information. How are you, ordinary diploma students who are ordinary diploma in electronics and telecommunication engineering students? How are you again? Well, are you ready to learn electronics drawing? Well, so are you ready to understand the difference between electronics drawing and electronics drafting? Well, so before we discuss about what you are supposed to discuss in lecture 3, let us do the quick review of the previous lecture, which is actual lecture 2. So what was the title of lecture 2? Hello? So the title of lecture 2, I told you about the important terminologies of what? Electronics electronics drawing. What are the common terminologies that we are going to discuss? And then I have just told you only 5. It doesn't mean that there are 5. There are more than 5. But I've decided to teach you 5. And then you are free to look some other terminologies and common terminologies that we are using in electronics drawing. So the first one, the first terminology is called the drawing. Say drawing. Drawing. Say drawing. Drawing. What is drawing? I gave you 2 definitions of drawing. One of them is what? First of all, drawing is what? Visual art. But also, in order to do drawing, we need drawing what? Instruments or tools. But also, in order to accomplish our drawings, we need what? We need the surface where that we have to locate our drawing. It can be a 2-dimensional surface or multi-dimensional what? Surface. Then the second terminology, it is what? Engineering what? Engineering drawing. What is engineering drawing? First of all, engineering drawing, it's a technical what? Technical what? Language. It's a technical language. And this engineering drawings is actual describing about what? About how the product or machine or component, how it has been component, it has been what? How it has been has been designed, how it has been constructed, how it has been. So this is the language that you may use to communicate about a particular product or particular engineering system, right? Because you have engineering drawings, you say also you have architectural drawing, right? And also you have musical drawings. We have so many drawings. We have cartoon drawings. Ask your neighbor, do you like cartoons? I know your neighbor doesn't like cartoons nowadays because you are old enough. But during your childhood, you have been expert in all cartoons. You knew all the cartoons, eh? Ask your neighbor, how many cartoons did you know? Okay, then we narrowed the concept. We had a big picture. Then we said in engineering drawing, in engineering drawing, we can have mechanical engineering drawings. We can have civil engineering drawing. We can have structural engineering drawing. We can have computer engineering drawing. We can have electronics engineering, or we call this just electronics drawing. Okay? We call mechanical drawing, right? We call civil drawing, structural drawing. So we have different fields of even in mining, say mining. So we have some drawing special for the mining. To mine what? To mine the raw material from the earth's surface. Are we together? And I told you that drawing is a very important language which can present your idea and how these components are interconnected. So the study terminology is about what? Electronics drawing. What is electronics drawing? Simply, this is a what? Graphical what? Representation. Who can call Angelica? Representation. Oh, you are warmly welcome. Graphical, say graphical representation. Okay, sit with your friend. It's better to have a seat with your friend. Graphical what? Representation. Say graphical representation. So this is graphical representation, which is actual shows how electronics components are interconnected. Okay? How they are connected. And also how they work. How they work together to solve a particular what? Problem. Right? The first terminology is what? So did he learn 5 or 4? Electronics what? Drafting. What is electronics drafting? Mambo haya. Repeat again. What is electronics drafting? Read.
The process of creating technical drawings and schematics that are used to design and manufacture.
So it's a process of creating what? A technical drawing. And what? And schematics. But I represented him, or I told you that in engineering we always start with problem. Say problem. Then we develop idea, and then we go for electronics drawing, and then we'll have electronics drafting. So electronics drawings is actually presenting the idea how the components are working, but the limitation of electronics drawing, it does not discuss anything about how that system will be interconnected, or how that system will be constructed, or how that system will be built, how that system will be implemented. While electronics drafting is actual thinking or focusing on how that system will be constructed. Are we together? That the case? Did I leave the homework? Yes, that is homework, aka it is assignment number 1. And the solution for that assignment number 1 you will get in lecture 3 and also in some other reference. So I will explain at the end of this lecture what should you do in that assignment. Did you do? You have done, Okay. Others yes, others no. Let us see what you have done and what you are supposed to do. So let us discuss. So class A Introduction to electronics drawing.
Introduction to electronics drawing.
Yeah, so tell your neighbor that we are still introduced about what we are supposed to learn in electronics drawing. And then we are in lecture 3. Read what the name of lecture 3? Difference between
electronics drawing and electronics drafting.
While the assignment it is explain 7 differences between electronics drawing and the electronics what? Drafting. Okay? So, I'm not going to mention those 7 differences. I will teach you the differences in a different style. And then you have to listen and understand. Then you have to go and summarize. But you have to add some materials until you answer the questions for assignment 1. Are we together? So listen careful. Because electronics drawing and the electronics drafting are used interchangeably. Okay? Thank you. Are used interchangeably? They are contradicting. If you're not careful, you may say that electronics drawing is electronics drafting. Why it's not true? Okay? Okay. So again, say difference between electronics drawings and electronics drafting. Okay. So let us start. We say that the terms, these 2 terms, the terms electronics drawing and the electronics, the term electronics drawings and electronics drafting are often used interchangeably, but they can, this is what you have to start in that assignment. You could have started with. They can have differences or different connotation. Difference in connotation depending on the context. Depending on the context. So in a number of books and materials, these 2 words are used interchangeably. Say, are used interchangeably. They seem like they have a close meaning. Right? Sometimes you may call electronics drawings, this is the electronics drafting diagram. And sometimes you may be given electronics drafting and then you say, this is the electronics drawing. That's the meaning. Okay? But in reality, electronics drawings and electronics drafting are electronics drawings and electronics drawings and electronics drafting. They can have what? Different connotation. Say connotation. Say connotation. Those who come from English medium, what the means of connotation in Swahili? We are Swahili people. Tell your neighbor, I am a Swahili people, aka Bongo people. Tell your neighbor, I am a Swahili person, aka a Bongo person. So connotation, it's a vocabulary. Help me. So what the means of connotation in Swahili? Connotation is Swahili. Did you go for English medium? Ufagio na kidum. Now every student will say no. Angelica? Every student now did not go for English medium. Good luck. You're afraid? You went for English medium. Tell us what the means of connotation in Swahili. No idea. Sure. Your English medium teacher did not cover that. So, listen. Simply, I don't know the meaning is right, but I can explain what does it mean about connotation. It means these are the closely related words, but they have some different depending on the context. Say context. What does it mean about the context? For instance, they can have different depending on the context of types. The types of electronics drawings are not the same with the types of electronics drafting. Are you together? They can have the difference in terms of clarity. Maybe you can find that most of electronics drawing are clear rather than electronics drafting diagram. Are you together? So it depends. They can have also a particular connotation depending on the complexity. Are we together? Are we together? Yes. Yeah. It's just like if you have a friend called Johnny Shaban. Or maybe Johnny Shaban. Okay, let's say Johnny Shabani and Johnny Juma. So Johnny is, you may look at that's the same person. But once you go for the second name, you see the difference. That is John Shabani, that is John. Okay. So, if that is the case, and we say there are some differences, now we say that the following is a discussion about the differences between electronics drawing and the electronics drafting. So this is the breakdown, drafting. So we are going to discuss one after the other one, and then you'll have a responsibility to compare them. Right? Let us start in our discussion with electronics drawing. Again, say electronics drawing. Say electronics drawing. Yes, it's still morning. So you say that an electronics drawing is any type of visual representation, is any type of visual representation that illustrate. This is explanation, it's not the definition. Illustrate electrical and the electronic circuits, electrical and electronic circuits, electrical and electronics components, electrical and the electronics components, also it illustrates electronics and the electrical system. So in short, electronics drawing is illustration of electrical and electronic circuits, or it's illustration of electrical and electronic circuits, or it's illustration of electrical and the electronic system. Class operating, listen and watch. So an electronics drawing is any type, say any type. Any type. Or visual representation. So say visual representation. It's not imaginary, it's visual. You could see it. Because you can have imaginary representation. So it's a visual representation of what? It's a visual representation that illustrates what? Electrical and the electronic circuit. So if you want to know about electronic circuits or electrical circuits, you should know about electronics drawing, because it's the one that will give you or will illustrate about that electrical circuit, so electronic circuit. Also, we say that the visual is the type of visual representation that illustrates what? Electrical and the electronic circuit. Electrical and electronic circuit. If you want to learn about the electrical components, or hello. I said stop writing, listen, and watch. In case you want to know about electronics components, say electronics components. Can you mention one example of electronics components? A diode. Another example of components, electronics components, a transistor. Another example of electronics components, operation amplifier. Another example for electronics components, hello. So, in case you want to know, another example of electronics components is integrated circuit. Another example of electronics components, oscillators, etc., amplifiers. All of them are electronic circuit. Also, we have drivers. We have converters, electronics converters. So, in case you want to know about those electronics components, one of the languages which might simplify you to know them is electronics drawing. But also, in case you want to learn about electrical and electronic system, it's better also to understand about their electronic circuit drawing. 1, 2, 3. Read this sentence from beginning to the end loudly and happily.
An electronics drawing is an area of visual representation that illustrates electrical and electronic circuits, electrical and electronics components, electronics and electrical systems.
Okay. So, did you understand? Eh? Did you understand? Yes. Well, again, another important sentence, we say that these electronics drawings, what do they represent? These electronics drawings are, or electronics drawings communicate about the working principle, communicate about how the working principle of getting of electronic system, of different electronic system, are designed and function. So these are very important to electronics drawing because they really communicating the working principle of different electronic systems about how they have been designed and how they function. So you say about design is just interconnecting the electronics components or interconnect different electrical components. Okay? Okay? Eh? So you say that electronics drawing okay, electronics drawing includes the following diagram. include the following diagram. The first one, in electronics drawing, you can find a diagram that is called the circuit diagram. Class, say circuit diagram. Say circuit diagram. So circuit diagram is a good example of electronic shorty drawing. It's a good example of electronic shorty drawing. Say circuit diagram. That's how you say that this is the any type of visual representation that illustrates electrical and the electronics circuits. So that the diagram represents about your circuit. It does not represent about components. It does not represent about your system. It represents about your circuit. Say again, circuit diagram. Again, circuit diagram. So simply, this circuit diagram is also known as schematic circuit diagram. Schematic circuit diagram. So simply, the schematic circuit diagram or the circuit diagram show diagrams. This actual shows, okay, shows how the electrical and the electronics components are such as electronics components such as resistors, such as capacitor, such as inductors, such as diodes, such as transistors, such as drivers, such as converters, such as integrated circuit, are interconnected within the electronics circuit. So separating, listen. These schematic circuit diagrams are the one of the type of electronics diagram or electronics drawing, or are the ones of the electronics drawing that we have, show how the electrical, say electrical components and the electronics components such as resistors, capacitors, inductors, diodes, transistors, drivers, converters, integrated circuit or IC are interconnected. Within the electronic circuit. Okay? Okay? Yes. So let me give you a simple example. We will discuss. This is This, I think that we might have, it's one of the topic, we mentioned a topic that's called schematic diagram. It's a topic. So we'll discuss in detail. I'm just introducing to you and to show the difference between electronics drawings and electronics drafting. A simple example of a schematic circuit diagram that consists of electrical components. Say electrical components. In basic electronics, you have to be taught about electrical components and electronics components. What the difference between electrical component and electronics components? Ask your neighbor. What the difference between electrical components and electronics components? Okay. I think your neighbor told you a lot of stories. To simplify the concept, just ask your neighbor to mention 3 examples of electrical component, and then you'll mention to your neighbor 3 examples of electronics component. Because in case of difference, it might be a difficult question for your neighbor. I say discuss to your neighbor. This is interactive classes or lectures. You are not discussing. These are your 2 neighbors. Yes. So why are you not talking? Okay. Listen. Electrical components, listen. Electrical components are the, we call them, are the components which have been made by using only conductors. We have 3 types of, we call them 3 types of what? Of material, of electrical material. We have conductors, we have semiconductor, we have insulator. So simply electrical components are the one which are made by what? Conductors. And you know conductors, they allow flow of electric currents by using what? Only electrons. And what are the names of those electrons? We call them valency electron. Example, what example? Tell me one example of conductor. Aluminium, right? Copper, iron, Zulfa, silver, then constantan, gold. Okay, so for instance, when we talk about electronics components, these are the components which are made by semiconductor only. That's the difference. Semiconductor, they conduct electric currents by using what? Electrons only, or holes only, or recombinations of electrons and what? Yes. It's simple like that. That's what you have to be taught. In basic electronics, you are not just here asked to be taught about electrical components. No, to know the difference first, and the simple difference that you don't need to cram. Right? So electrical components are made by what? Conductors. Electronics components are made by what? Semiconductor. That's all. Then, in these examples, tell me, is a resistor electric component or electronics component? Or both? Is a resistor electric? If you've understood, hello, it's not the time for writing. It is a resistor electric component or electronics component, or both electric and electronics component? You are learning basic electronics. What have you been learning? You've been learning calculating the resistance of the resistor by using color code. That's all. Eh? So you don't know whether a resistor is electrical or electronics component. Electronics component. Do you have semiconductor and resistors? Resistor, it's electrical component. Listen, hey! Resistor, it's electrical component, but we may use it in electronic system. A resistor is just made by conductor, either carbon, most of the resistors carbon, carbon resistors, and some other materials. Are we together, class? Are we together? Yes. Yeah. So listen, a resistor, it's electrical component, but it's usually used or is often used in electronic system. So when you hear somebody tell you that a resistor is electronics components, okay, you have to understand that he just see confusion, or maybe he may confuse. You might confuse. Why it's called as electronics components? Because in most of electronic system you'll find a resistor. So people sometimes might think that this is electronics component. No. Is a capacitor electrical component or electronics component? So now you have discovered the secret, eh? Electrical. Is an inductor electrical component or electronics component? Electrical. Right? But remember that a capacitor is electrical components, but it's often used in electronic system. Are we together? Yeah. So when you hear maybe a teacher or your friend say, a capacitor is the electronics component, don't have a battle. Just understand that because your neighbor or your teacher has been seeing a number of capacitors in the electronic system, that's why that he said that it's electronics component. Right? Is a diode electrical components or electronics component? Why it's electronics component? Is a transistor electrical components or electronics component? Are the drivers electrical components or electronics component? Give one example of a driver. We don't talk about a driver who is driving a car. Are converters electrical or electronics component? This is the electronics component. However, that it might consist of electrical components. But the main part is electronics component. This is semiconductor. This is semiconductor device. It consists of resistors and whatever. This is pure semiconductor. Integrated circuits is a good example of electronics component. Are we together? Wow. So example of a schematic circuit diagram. Example of simple schematic circuit diagram which consists of electrical and electronics component is this one. Leave it. Good morning. Good morning. Nowadays, electronics drawing are drawn by using a pencil. So I don't expect any students to draw figure 1 by using a pen. It's illegal. Tell your neighbor it's illegal to draw by using a pen. A schematic circuit diagram. So this is a good example of electronics drawing, and it's a good example of schematic circuit diagram. I guess say schematic circuit diagram. Schematic. Tell your neighbor schematic circuit diagram. Schematic circuit. Yeah, it could be good if tonight you dream about schematic circuit diagram. So stop writing, stop drawing. Tell your neighbor stop writing, stop drawing. Listen. There's a difference between schematic diagram and circuit diagram. We used to have schematic circuit diagram and also used to have a schematic diagram. There's a difference between a schematic diagram and a schematic circuit diagram. I will teach you the difference later on. But currently, this is the arrangement. Listen, this is the electric component. This is the electric component. This is electronics components. But sometimes you may call them all of them are electronics components. Is fine because they be used in electronic system. But that system is not electrical. It's electrical system, but it's electronic system. Okay? The word electrical and electronics, we use them interchangeably. You should not confuse them. Why? Because the type of the signal that will be flowing through this system, it's electrical. I say stop drawing, stop doing whatever you are doing. This is the switch, this is the cell, this is the battery. Okay? Always we call this in electrical engineering or electronics engineering supply voltage. Suppose that this is 5 volt. Okay? So it's 5 volt. Then what are the directions of flow? Electric current. This is the switch. This is called what? Switch. Say switch. We are going to discuss about schematic symbol. This is the symbol for resistor, symbol for the general purpose diode, schematic symbol for the general purpose diode. Right? And then this is a battery, not a cell. This is the battery. So if you close the switch, then there is the flow of electric current from the positive terminal of the battery towards resistor 1, towards resistor 2. And then at this point we have a junction. This is the junction. This is the very important junction. Then we have division of current. So we still have a series flow of electric currents. For this case, we are going to have parallel arrangement. Then we have parallel. So divisions of current, and then we have the connections. This is another junction. Then we have the continuous flow of electric current. So this one, we can call it in electric or in electronics as total current. And then this one, we may call it current 1. And this one, we may call it current 2. So you can see that it's actually representing what? Representing how these electrical and electronics components are interconnected. For instance, how R1 and R2 are interconnected. I said, stop writing. How R1 and R2 are interconnected. Series. So once you find that R1, one terminal of R1 is connected with one terminal of R2, even if nobody will tell you what is happening, you have understood that language. It's a series connection of 40 resistors. Right? And then how diode 1 and diode 2 are interconnected? Parallel. Why they are interconnected parallel? Because they have a common junction. It means anode and anode are interconnected. Cathode and cathode are interconnected. So even if I draw this diagram, I don't need to tell you that This the one and the two are interconnected parallel. You will understand because we say drawing, it's a language. Okay? So once you see this drawing, it will tell you what does it mean. Are we together? How is the battery connected with other one? They have been connected in what? Series. So this is the electronics drawing. It's not the electronics drafting. Hello? Ask your neighbor, do you understand or you don't understand? The second example of electronics drawing is called the wiring diagram. Say wiring diagram.
Wiring diagram.
So wiring diagram. So you say that these are the electronics drawings that shows how electrical wiring should be physically laid out. Typically in the context of a product or installation. In the context of product or installation. Separating. So wiring diagram, it's another example of electronics drawing or electrical drawing. Because when you talk wiring, we may do wiring in electronics, we may do wiring in electrical engineering. Okay? So this is one example for electronics drawing. And these drawings actually show how electrical wiring should be physically laid out, typically in the context of product or in the context of installation. I said separating. What does it mean? In this diagram, wiring diagram does not show how one electronics component is interconnected with another electronics component. For instance, this is the wire, right? This is the what? Wire. But we don't call this diagrams, it's a wiring diagram. No. We are going to discuss in detail about it. It's one of the types. Because in lecture 4, I will teach you about the types of electronics drawing on Monday. Okay? So one of the type of electronics drawing is wiring diagram. So I will introduce to you, but later on we'll be discussed in detail. However, the wiring diagrams, we are learning another module called the installation and what? It's called electrical installation and what? Electrical circuit and the installation. Well, so you'll be learning a lot about wiring diagram. Are you together? Yeah. But simply we say that these diagrams shows how electrical wiring, say electrical wiring.
Electrical wiring.
How electrical wiring should be physically laid out. This is not a physical layout. This is a logical layout. It's a conceptual layout. So you say physical layout, that for instance you have, maybe you have one item here, or let's say that when you talk about it, suppose that here you have a socket, and here you have a main switch, and here you have maybe a lamp, and here you have, this is a socket, a wall socket, just like that one. This is the lamp, this is the main switch. So actually you have to lay some cables, right? From the main switch passing through MCB and whatever, so that there is a flow of electric current. But wiring diagrams also we use oftenly in telecommunication. For instance, if you wanted to have a landline, maybe internet connection of one office with another office. So cables will be laid out physically. Maybe from departments of electronics to the departments of civil engineering. From departments of civil engineering, so it means that you have to draw the diagram. Otherwise, you find that you'll have a rough installation or a rough rough arrangements of the wires within the product. Class, are we together? So we need to have wiring diagrams because we use it often in designing, in all designs of electronics devices. How many of you have seen the old computer or the oldest television receiver? Have you ever opened it and see the inside of the old computer or old mobile phone? You haven't seen? Okay, you may visit, I think that it's W153 to see. The old computers and even old mobile phones, telephones, and all the television receiver, they had a lot of wires that carrying electric signal from one point or one component to another. What? Are we together? So there's a lot of wires, Nowadays, there is the technology that's called the bus. Say bus. Yes, bus technology. So bus technology, you just find the one cable which is thin, but it consists of 10 wires within it. Are we together? Are we together? Yes. So that is all about wiring diagram. So wiring diagrams is not electronics drafting. It's electronics It's electronics do you have a question? Do you have a question? You have a module that's called installation, right? You learn a lot about that. Then, the third example of electronics drawing is called this now. It's powerful. It's called the block diagram. Class A, block diagram. Say again, block diagram. If you want to think about it, when you call maybe electronics drawing is your particular favorite song, then block diagram, we may call it's a chorus of the song. Any song has a chorus. Tell your neighbor, any song has a chorus. Whether it is a worship song or praise song or bongo flavor song or traditional song, it has a chorus. Chorus in Swahili we just call tikitikio. Any song should have a verse. Any song should have maybe one verse. Some songs can have 1, 2, 3, 4, depending on the length of the song. But the chorus is mandatory, right? And the chorus is always sung repeatedly, right? And if you listen any song, it will be easier for you to go or to sing, to rethink that song, the chorus part rather than the verses. Are we together? So if you want to talk about electronics, it's a particular favorite song, then block diagrams, it's a chorus. Say block diagrams, it's the chorus of the song called the Electronics Drawing. Okay, can you sing to your neighbor? The chorus that's called the block diagram. So this electronics drawings show a high level, showing a high level overview of a particular electronics system. A particular electronic system by using blocks and that are interconnected logically by arrows. So block diagrams is the one of example 40, electronics 40, electronics 40, drawing. In block diagrams, actually these electronics diagrams, they show high level, say high level, overview of a particular electronic system by using blocks that are interconnected together or interconnected logically by arrows. So block diagrams is not electronics drafting. Okay? Ask your neighbor, can you draw to me one example of block diagram that you know as a serious electronics and telecommunication technician, basic technician? Okay, draw one block diagram to your neighbor. Draw one block diagram to your neighbor. You learn the basic electronics, you learn about electrical installation, whatever. You are learning so many things. So draw one block diagram to your neighbor on the rough paper, rough part, not on your exercise book, because you don't trust your neighbor. First of all, ask your neighbor, have you ever heard about block diagram? Because you may draw something that you don't know. A simple okay. Example of block diagram, just to give you the overview. Example of block diagram. Stop writing. This is the simple example of the electronics block diagram. First of all, we use blocks. Block diagrams is a topic we'll discuss in detail later. It's a topic, right? Yeah, and you'll draw a lot of block diagram. Tell your neighbor, in this course you'll draw a lot of block diagram, whether you like it or you don't like it. Tell your neighbor, in this course you'll draw a lot of block diagrams, whether you like or you don't like. Are you still talking to your neighbor? Okay. So, listen, stop writing, look on the blackboard. Tell your neighbor, stop writing, look on the blackboard. Then we have another block. Then you have another block. So this block simply we call it power supply unit. And this block we call it input unity of our system. I say don't write, don't draw. Listen. This one we call it control unit, or sometimes we call it system, control system, we call it our system, and sometimes we call it the brain of the system. And this block we call it output. Output unit. We say that the diagram show the high level. I say this stop drawing. Look your neighbor. Then we say that these are the blocks. Say blocks. How many blocks do you have? 4. Then we are going to interconnect it logically. Any electronic system. Do you think that you are far from me? Huh? Did you think that I can't see you? Any electronic system may be described or represented in high level by using 4 blocks. Whether it's a mobile phone, whether it's a computer, whether it's an iPad, whether it's a saver, whether it is telephone, whether it's telecommunication towers, or maybe it means any, whether it's a radio, any electronic system, whether it's a printer, whether it is a photocopy machine, it can be represented into the high level or into the high level with by authority of only 4 blocks. We'll discuss them later. Okay? The first block, which is very important, is called the power supply. Say power supply. All electronic systems need power in order for them to work. Okay? That's why I would like to ask you, can you use your mobile phone while the power has drained out and you don't have the mobile charger? You can't. Then another one is called the input unit. Say input unit. Say input unit. Most electronic systems, most of them, millions of them, they have input. They need some input, whether from the human, whether from the environment, whether from another system, it depends. But they have a part where we call it input. For instance, in your mobile phone, you can talk. So while you are talking, it means that you are supplying the input to the microphone. So the microphone, it's the input unity of your voice communication. Hello. Then, it's just like yourself. Tell me, your neighbor on your left-hand side and right-hand side, does he or she has a brain? I believe the answer is yes. Similarly, most intelligent and modern electronic system, they also have brain, just like you, to make decision, right? To receive information, and also to send the signals, to take an action. It's just like your brain, right? That's why they work intelligently, even more than a human being like you and I, but not more than the one who made it. So that's it. That unit you call the control unit, or system unit, or brain of the system. Then every electronic system has the output unit. Say output unit. Output unit. Say output unit. Output. For instance, if I make a call, I'm calling you. Hello. It's Olenjolain who is talking to you. How are you going to receive the output of my voice? By using your mobile speaker. It's a speaker that actual will give you the, or will give you the will give actual that will help you to receive the information that I'm communicating to you. Hello Jackson, how are you? This is Olenjolain, and I would like to tell you that today we'll have a class. So it means that my microphone, my mobile phone, if you didn't reply, it means that I've introduced the input on the microphone, and then Jackson is using the output, which it's actually it's a mobile speaker. Are we together? Those are the simple examples. So if that's the case, listen. First of all, before the input works, needs power. For instance, of the input components in your mobile phone, it's a camera. You cannot take a video while your mobile phone does not have charge. Can't you? No. You cannot take photos while your mobile charge it does not have charge. Means the battery is totally drained and don't have the mobile charger. You can't. Can you? No. Why? Because there is no power supply on the input, which is the camera. The camera needs power. Hello, 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 left winger. Lefty, lefty. Again, this control unit, it cannot work without power. The brain, just like your brain. If you did not eat for 10 days, can your brain work? No. 10 days is a lot, yeah? 1 day. Okay. Also, the output will not work if there is no power supply. For instance, your mobile display cannot display any information. Hello, late comer. Late comer. So, for instance, does your phone has a display? Eh? Can you see anything on the display while your mobile phone does not have any charge and it's not connected to power? No. Eh? No. Otherwise, you are what? A witch doctor? Jackson says that otherwise it's a witch doctor mobile phone. So once the input takes the input signal, it has to send to the brain. And then once these brains process the information, it has to send the output to the block of output. That's why I told you, and I would like to repeat. I said, listen and watch. Wewe! Mwangalie macho yake. Mazuri kama alivyo. Listen. I told you that engineering, we are the engineer, or in engineering, actually we are not doing anything new. We are just maximizing to use what God has created. This is just a copy of what God has created. And this is the actual architecture according to the human being. For instance, yourself, you have some input sensory organs, isn't it? First of all, your power supply is from what? Food. Right? Once you take a food, there are some enzymes. Right? Which will what? Digest the food in order to get the nutrients. And those nutrients will be fed to the blood system. Right? So you can walk, you can talk, you can cry, you can laugh. So that is the power supply, human power supply. But you have some input, which we call them input sensor organ, right? One of the input is what? An eye. An eye just representing what? A camera. Another input is what? An ear, right? An ear in engineering representing what? A microphone. Another input is what? A nose, right? A nose representing what? A sensor in engineering. Another output is what? Mouth or a tongue? A tongue. What the function of the tongue? To test. We have also some electronic sensors which their main function is to test. Right? Another sensor organ is what? Input sensor organ, skin. We have also some electronic sensors which actually test the signal once something happened through its own environment. So just see it's a copy of what God has created. But in terms of devices, not in terms of the biological people. Are you together? Do you have brain? What the main function of your brain? Different functions, is it? Including none meaning okay. I mean that including stupid things which are not important in your life. Okay? Then we talk about output, right? Show your neighbor one of your biological output. Output. Do you know output? One of the output for the human is the mouth. The mouth is an output. Now I'm trying to output what I know to you. Right? Another output? Another important output organ, it's a hand. So now I'm using the biological energy to write. This is the output. Another output? Legs, right? Legs. So if you cannot produce the output on the legs, you cannot walk. So if you are walking, you are providing the output. Another output? Stomach, or the stomach is input. The general block diagram of multi-electronics system. You can draw and label. So I've taught you 3 examples or 3 types of electronics drawing. Now let us conclude and then move to the electronics drafting. So from that discussion we say that the focus of an electronics drawing, the focus of an electronics drawing is on representing the information clearly and accurately. Clearly and accurately. Clearly and accurately to explain or visualize an electronic system. So this is not before. Electronic system. Rather than creating details or creating detailed construction, detailed construction or manufacturing data. or manufacturing that. So this is the summary of what electronics drawing is all about. Subwriting, what's electronics drawing? So the main focus of electronics drawing is representing what? Information. First of all, clearly, say clearly. Clearly. Say clearly. Clearly. Hello, Diana. Clearly and accurately. Presenting information clearly and to explain or visualize an electronic system. So this will explain about a particular electronic system or visualize about a particular electronic system rather than creating detailed construction and the manufacturing of the product. So that's the main focus of electronics drawing. For instance, this one is actually show you the relationship between the four main parts. But there's no any information about the size of input unit. There's no any information about the weight of the input unit. There's no any information about the dimension of the input unit. Are we together? Are we together? But just explain you how the input is interconnected with the brain and how the input is interconnected with the power supply and how the brain is interconnected with the output. That's all. You get some information with a high level information or low level information, but actually does not talk anything about the construction of that system or manufacturing of that product. Class, are we together? Yes. So this is one of the limitations of electronics drawing. And the limitation of electronics drawings, it's an advantage of electronics drafting. Class, are we together? Yes. For instance, we have these students and that students. The disadvantage of these students is an advantage of presence for this student. And the disadvantage of these students is the advantage of presence of this student. It means electronics drawing solve particular problems, but it has limitation. So the limitation of electronics drawings are the advantage of electronics drafting. And the limitation of electronics drafting are the advantage of electronics drawing. Class, are we together? Yes. Is it clear? Yes. Yeah. So in this discussion of electronics drawing, I show the strengths of electronics drawings and weaknesses of electronics drawing. So did you understand this discussion? Yes. Do you have a question? I will be surprised to have more than 50 students and none of them will ask a question. You know, most of my students, they used to tell me that, sir, we don't have questions because you've answered all of my questions when you've been teaching. A question about electronics drawing, what we have discussed? Brother? Why? You are sick. You are still thinking. So when will you finish to think? Then you can ask a question. Madam? Rhoda? You don't have a question. Brother? Sure. So it's clear. So I can give you test one. Now. Okay. So if that's the case, if it is clear, thank you very much for understanding. Tell your neighbor, thank you very much for understanding. Tell your neighbor, my neighbor, thank you very much for understanding today, lecture 3. Say electronics drafting. Again, say electronics drafting. Ask your neighbor to define electronics drafting for you. What is electronics drafting? Without checking from the exercise book. My neighbor, what is electronics drafting? Define to your neighbors. It's a current process. What is electronics drafting? Is a process. You just claim one definition. I thought that you could have even three. Because I just gave you one, I expected you to go and find some other three definitions. Go and clean this. Yeah? I gave you one definition. I expected today that the day before yesterday you found one definition of electronics drafting. Yesterday you found another one. So I expected to come with two new definitions of electronics drafting. Unfortunately, you came with the one I gave you. So in electronics drafting, what do we say? Listen, this is the first sentence that we are making. Electronics drafting, class A, electronics drafting again. Electronics drafting is a more technical process This is the more technical process. More technical process that involves creating precise, standardized, creating precise or standardized drawings. Standardized drawings for the production, for the construction, or for the implementation or for the production of electronics systems or devices. Electronic systems or devices. The electronics drafting also involves a set of specific convention, and technical drawings. And technical drawing standards. Hello, Liatu. What's going on in your mind? Okay, so let us grasp the understanding about what you have written here. Stop writing. Electronics drafting, say electronics drafting. First of all, it's more technical process. It's more technical process rather than electronics drawing. That's the meaning. It's more technical process that involves creating precise, standardized drawing for the construction or implementation or production of electronic system or devices. So remember that in electronics drawings we don't have standards. We don't have to follow the standards, right? And also in electronics drawings, okay, we are not focusing much on precision. We are focusing much on the accuracy. You have to know the difference between precision and the accuracy, right? Then after that, what the main goal of electronics drafting? To construct an electronic system or electronic device, or to implement electronic system or electronic device, or to manufacture electronic drawings or electronic device, or to produce electronic system or electronic device. Okay? Okay? Yes. Then we say that the electronics drawings also involve a set of specific convention and technical drawing standards. Say technical drawing standards. Say technical drawing standards. What the SCI unit or what the standard of mass? It's kilogram, right? What the standard of length? It's meter. It means that there are some standards which have been said. So in case of electronics drafting, we have also to learn about technical drawing standards. So in electronics, we have mainly two technical drawing standards. One is called the it's a standards which has been laid out by Institute of Electrical and Electronics Engineering. Institute of Electrical and Electronics Engineering. In short, it's called IEEE standards. Remember, in electronics drawings, we don't follow standards. Are we together? We don't follow even IEEE standards. The second standards that we follow in in drawing electronics drafting or in electronics drafting is called IPC standards. Go and find, this is the short term. Go and find the long term of IPC. Class, are we together? Say Institute of Electrical and Electronics Engineering. Institute of Electrical and Electronics Engineering. AKA IEEE. AKA IEEE. Okay, so is it clear? Is it clear? So in electronics drafting, we have to know or we have to learn and apply technical drawing standards or technical drawing or technical electronics drawing standards. Not technical mechanical drawing standards, no. Right? So this is the institute that one of its role is to set the standards. Are we together? Ask your neighbor, what's the standard of your stomach in case of taking food? 1 kilogram of rice. Can you take 1 kilogram of rice? Can you finish in a single meal? 1 kilogram of rice. So the electronics drafting, includes the following. Parts. So the first part that we have in electronics drawing is called the detailed layout. Detailed layout drawing. Detailed layout drawing. Detailed layout drawings. Detailed layout drawings. Say detailed layout drawing. Say it.
Detailed layout drawing.
Again.
Detailed layout drawing.
Again.
Detailed layout drawing.
So this is the one type of electronics drafting. Detailed layout drawing. Even the name, which shows the difference between electronics drafting and electronics drawing. This is too much detail. That's why it has been called detailed. So that one is less detailed. Oh, I'm trying to answer your assignment, eh? Yes. Because I love you so much, isn't it? Are you sure? Of course, eh? Okay. So the detailed layout drawing show the printed circuit board or PCB board, printed circuit board layouts showing exactly position, showing exact position of the components and the traces or roots. So simply that the brief descriptions of detailed layout drawing. Separating, listen and watch. Again, class A, detailed layout drawing.
Detailed layout drawing.
AKA we call it PCB or printed circuit board. Say printed circuit board.
Printed circuit board.
So listen. So these are the drawings, or are the electronics drafting drawing, or it's the one of electronics drafting drawing that shows the printed circuit board layouts. Say layout. Layout. Also, it shows exact position of the components and traces or roots. What does it mean? I say stop writing, look on the blackboard. Tell your neighbor, look on the blackboard. Refer figure 1. Open figure 1. Refer figure 1. That is electronics drawing, and that's called schematic circuit diagram. Let us try to draw it at the electronics drafting. Okay? Okay? And let us start from resistor 1. You see resistor 1? So in electronics drafting, listen. What are we going to draw? A resistor, it has 2 terminals. Right? And resistors have different physical size. We have small resistor, moderate resistors, and large resistors in terms of dimension. Okay? So remember, in schematic, we use this schematic symbol to show the symbol of resistor, right? In detailed layout diagrams, we are not using the schematic symbol. We are just using the only 2 holes. These 2 holes represent the resistor. Why it is 2 holes? Simple. The physical appearance, remember that we say electronics drafting deals with construction or manufacturing or implementation or what? Production of the actual thing. While electronics drawing is just to give you the big picture. Right? So the physical appearance of resistor is not this one. This is not the physical appearance of resistor. This is the schematic symbol. Right? What the physical appearance of a resistor? Any resistor or most of resistors, they are cylindrical in structure. They are cylindrical in what? Like this way. This is the cylinder. Then this is, we call it color bands. So you can find that this resistor, it has what? Dimension. Okay? So what do we need for the physical implementation? For the physical implementation, we just need a hole to plug terminal 1 and a hole to insert terminal 2 of the resistor. Hello? Oh, listen and watch. So that's why in the PCB layout or in construction, we don't need to draw the physical resistor the way it is. We just need 2 holes. That's all. This for terminal 1 of the resistor, and this will place terminal 2 of the resistor. Hello? Ha 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 ha. Tell your neighbor electronics drafting is beautiful. Then we are going to draw the detailed layout of resistor 2. So this one, we can call it resistor 1. Okay? Refer. This is refer. Refer what? Figure 1. Okay? And this one is resistor 2. We are still drawing the components only, because we say that this shows exact position of the components. Are we together? This is the simple example. This is the pen. Okay, this is something which is compatible with a pen. You can either fix it here or you can fix it here. You cannot fix it here. Right? So that's what we are doing there in physical implementation. Okay? Then, if that's the case, this is resistor 2. What another electronics components that we have? Diode. So how many terminals does the diode, general purpose diode has? Only 2. Anode and the cathode. Hey. Okay. So we just need 2 holes where we are going to place a physical diode. And this one, we'll call it diode 1. Then we need another component is what? A diode. So this is what? Diode 2. Another electrons, another component. I say refer figure 1. Switch. How many terminals a normal switch has? Only 2. So this one and this one will be the terminals that present what? A switch. Another component? Battery. How many terminals does the battery have? 2, right? Positive terminal and negative? Yeah. Okay, so let us place it here so that to have the same architecture. So this is battery. Did it represent all the electrical and electronics components? Did it represent them? Have you finished all the electrical and electronics components in figure 1? Yeah. So the next thing or the next task to show the traces or roots. So now we are going to do wiring of those electronics components. Right? How are you going to wire? This is terminal, let's say terminal 2 of the resistor. So we are going to use the copper within the PCB board to connect resistor 1 and resistor 2. Right? If the variable, we are going to use soldering wire. Now you don't understand about PCB board, don't understand about soldering wire, you are already in the industry of electronics, you will understand them. And especially if you are connected with me, I'm always committed to teach students about those. But if you'll be disconnected, okay, maybe God will teach you in another way. Okay? Then another terminal of resistor 2 is connected with one terminal of diode 1. Okay? Then terminal 1 of diode 1 is connected together with terminal 1 of diode 2. Right? And terminal 2 of diode 1 and terminal 2 of diode 2 are connected. Okay? Then terminal 2 and terminal 3 of the diodes are also connected with with the one terminal of the switch. And then terminal 2 of the switch connected with one negative terminal of the battery. And the positive terminal of the battery is connected with terminal 1 of resistance 1. Then this is figure 3. We have finished. It may include the dimension that the figure 3. So the detailed layout diagram of figure 1. That's all. Tell your neighbor, electronics drawings and electronics drafting are very interesting. Okay, so there is one student who have asked the question about how can we draw the PCB or the detailed layout drawing. Well, that's a very interesting question, and I want to tell you that in context, I would like to tell you that electronics drafting does not depend, or electronics drafting depends electronics drawing. But electronics drawing does not depend electronics drafting. However, that you can take electronics drafting diagram and convert it into electronics diagram. Okay? So this is the simple flow. In engineering, we have to identify problem. Say problem. Then once you have a problem, you have proposed solution. Right? And that solution, we have to draw a block diagram. Say block diagram. Then by using a block diagram, we have to open these block diagrams and having schematic circuit diagram. And by using schematic circuit diagram, we can draw the layout or the detailed layout diagram, which simply called the PCB. So, in order to draw the schematic diagram, you need to draw first block diagram. In order to draw the PCB layout diagram, you need to draw the schematic circuit diagram first. Because schematic circuit diagrams show how components are interconnected. PCB layout shows or teaches you how those physical components will be interconnected. No, how will be interconnected during the construction. Are we together? Yes. Are we together? So this PCB layout, I have drawn it in mind. That's why I say refer figure 1. Figure 1 is a schematic circuit diagram. Are we together? However, that if you understand this electronics drafting, we can give you electronics drafting and we ask you to reverse the gear to draw the schematic circuit diagram. Hello? Tell your neighbor, are you still here or you're not here? And tell your neighbor, that's all about electronics drawing. Okay, so my dear students, I would like to say that this is the end of lecture 3. We did not finish about differences between electronics drawing and electronics drafting. I still have 2 examples about the components placement and assembly electronics drafting. So we'll discuss them in lecture 4. However, in lecture 4, we'll be discussing about types of electronics drawing. So this is the end. In case you have a question, don't hesitate to ask it. But in case that you don't have a question, make sure that you watch this video several times as well as you can. And then if that's the case, I would like to thank you for listening and learning about electronics drawing. You should not boast yourself that you are competent. This is still a fundamental skills. Stay connected and welcome in lecture 4. Share these contents to your friends who are pursuing either electrical engineering or electronics engineering. But let me know about some physical students that I have in this class, if they have understood or they haven't understood. Students, did you understand lecture 3? Yes. Did you enjoy it? Yes. Did you understand? Yes. Will you apply? Yes. Where are you going to apply? Not yet. Well, so if that's the case, let us congratulate you because you have done the work. I always appreciate my students. I don't know if my students appreciate me. That's none of my business. But for me, I appreciate my students who have been active, listening, asking questions, and understand. 1, 2, 3. Hongera. Imara. Wow. Thank you very much. See you in lecture 4.
Africa.